Okay, in this tutorial we're going to look at how we would describe and explain the changing discharge of this river, the Valency, in a place called Boscastle on the 16th of August 2004. Now, what we're exploring here is actually a very famous river flood that happened a few years ago, and the town of Boscastle was completely inundated with water and flooded, and it made national news at the time. But you wouldn't necessarily know that by just looking at this question. What you're being asked to do is to tell me, what did the river discharge do from 6 o'clock in the morning to 10 o'clock in the evening? Well, we can see by the black line what the discharge is doing. So the first part of this question, the describe, is where we tell the story about what the discharge did. The explain is where we give reasons. Now, the majority of our reasons are going to be to do with the changing rainfall, because obviously when rivers rise and then fall, that's because something to do with rain. But there is actually a lot of other things to do with the actual surrounding landscape. With the drainage basin of the River Valency goes a long way to explaining these rapid rises that we see, as well as this rapid fall in the discharge. So we're going to explore what possibly could be some of the reasons why this river's discharge shot up so quickly when it started raining. Okay, so let's have a look. How would I answer this? What are the key things I want to do to get my marks? Well, the first thing is we want to say is that the river, from 6 o'clock in the morning, the discharge barely changes over the first 4 hours. So at 6, 7, 8 and 9, the discharge is around about 1 cubic, and it rises maybe to about 2 or 3 cubics over the first 4 hours. Okay. That's the first thing. Very little change over the first 4 hours. What we then want to do is say, well, the next description is it rises from 9 to its first peak. So it rises from about 2 or 3 cubics to around about 50 cubics. So I get that from over here on the scale at 1 o'clock in the afternoon. So I've now got 2 marks. I've got my mark from describing the small change in the first 4 hours. I've got my second mark from describing the dramatic increase from 9 o'clock in the morning to 1 o'clock in the afternoon. I'm now going to give my first reason, okay? My first explanation. This first increase is to do with the first peak rainfall that happens at 9 o'clock in the morning, where roughly 10 millimeters of rain fell. And that sudden increase in rainfall at 9 o'clock is why the river started rising. I'm now going to say for the next 2 hours, from 1 o'clock to 3 o'clock, the river only rose a small amount, going from about 50 to 55 cubics. Okay, don't be worried if you're not exactly precise in describing the changes. As long as you say roughly, you'll get the mark. So what we've done there is we've described this change here. The next 2 hours is only a slight increase from about 50 to 55. Let's give a reason. Let's explain. Why is this? Well, from 10 and 11 o'clock, these 2 bars here, the rainfall slowed down. So there was less rain between 10 and 11, when it drops to around about 2 and 4 millimeters on those 2 hours. And that's why the river slowed down. There is then a dramatic increase in the river from 3 o'clock to the peak at 6 o'clock. Okay? And this dramatic increase is caused, first of all, by the peak rainfall for the whole day that happened at 1 o'clock in the afternoon, where roughly 14 millimeters of rain fell out of the sky. Now, if you do your maths here, that gives us, that peak rainfall to peak discharge is a 5-hour lag time. And you might want to say, the reason for this short 5-hour lag time, and if you remember, the lag time is the time it takes from the peak rainfall here to the peak discharge here. Why is there this short lag time? Now, that's not where we can talk about rainfall. We have to talk about the drainage basin of the River Valency. And there are a whole bunch of reasons why there's this very short period of time. So the first reason is because the landscape that Boscastle sits in has got very steep slopes. So it's a V-shaped valley actually, but you wouldn't know that. But if you say it could have steep slopes, You would then say, and this encourages water to flow fastly down the steep gradients to the river, and therefore when it comes out of the sky, it gets to the river very quickly. That would be your first reason. You could then say that the surrounding landscape, the rock, might be impermeable. And what that means is the surrounding landscape cannot soak up water. It doesn't absorb water, and therefore all of the water runs across the surface and gets to the river quickly. The third reason is that there are very few trees in the surrounding landscape, so it's been quite heavily deforested. It's mainly because it's agricultural. But if you say it's deforested, that means there's no trees to absorb, to slow the water's arrival at the river, and because of that, it's all just flowing across the surface of the landscape to the river very quickly. Our final reason, you could say, is that Boscastle is a town. It suggests that it might be an urban landscape, which is covered in tarmac and buildings and roofs. And as they don't absorb water but quickly channel the water off these urban landscapes into drains, this water is quickly getting to the river, and therefore the river's rising very quick. Now, I've just given you 4 reasons, all of which are possible explanations, using your knowledge about drainage basins, that tell us why the River Valency rose very quickly and only had a 5-hour lag time. Let's finish this answer off though. Let's describe from 6 o'clock the river level drops sharply till 10 o'clock in the evening, down to around about 10 cumecs. Why is this? Now, there's 2 marks for this. The first reason is it stops raining after 3 o'clock. So after 3 p.m. the rain stops, and therefore you'd expect the river to start coming down. Your second mark, why does it come down so fast? Well, you could then say it comes down so fast because there are very few natural stores in the landscape. There might not be much in the way of soils, or the soils might be hard and compacted because it is summertime after all, and therefore they're not absorbing water. Or if the soils are not allowing water in, and there's no natural lochs or lakes to store that water, then all of the water is just flushing out of the system. And that's why the river's coming down very fast. If the landscape's not holding onto the water, the river goes up quick, but it also comes down quick. Okay, so you've got more than 10 marks in this answer. Remember, the key to a good answer is you're always, to get your describe marks, you need to use the data from the left-hand axis. And whenever you talk about rainfall changes as a reason for the river changing, you should be giving data from the right-hand axis. You must also remember that some of your explanations shouldn't just be about rainfall changes. Some of your explanations should also be about the surrounding landscape, the characteristics of the drainage basin through which your river flows.